Hello bachcho, let's read the question. The question says that as a wave propagates, the wave intensity remains constant for a plane wave. The wave intensity decreases as the inverse of the distance from the source for a spherical wave. The wave intensity decreases as the inverse square of the distance from the source for a spherical wave. Total power of the spherical wave over the spherical surface centered at the source remains constant at all time. So, we'll solve this question. First of all, we will see what will be the key concept used in the question. The key concept used in the question will be when the wave is coming from a very far off source, the wave fronts are planar. So, on the basis of this key concept, we'll determine. So, for plane wave front, amplitude remains constant. So, intensity also remains constant. Now, we'll see for a spherical wavefront, amplitude of a wave is inversely proportional to r. So, intensity of a wave will be inversely proportional to r square, where r is the distance from the source. Also, all points on the spherical surface are equidistant from a point source. So, total intensity is independent of time. So, now we will check options. First option is given the wave intensity remains constant for a plane wave. We can see as the amplitude remains constant for a plane wave front, so wave intensity also remains constant. So option A is correct. Second one, the wave intensity decreases as the inverse of the distance from the source for a spherical wave. But we can see intensity decreases as the inverse of square of distance. So the correct option will be option C. And fourth one, total power of the spherical wave over the spherical surface centered at the source remains constant at all time. Since intensity remains constant, so and area is 4 pi r square. For a wave front, for a spherical wave front, r is constant, so power will be equal to intensity into area. As intensity remains constant, area remains constant, so power must also remain constant. So option D will be also correct. Hope you all understood it well. Best of luck.